Hello friends, welcome to my YouTube channel. Today we are going to cover our next topic, that is conversion from NFA to DFA. Okay. This is one question that says construct a FSM that will accept all the strings of 0 and 1 where last two symbols are 1 1. Okay, so this question means that we have to construct a final state machine which accepts all the combinations of 0 and 1, but the condition is the last symbol of the string should be what? 1 and 1. Okay, before this 1 and 1 there can be any kind of combination of 0 and 1. Okay. So directly constructing a DFA, that may be some tedious task. So first we will construct what? This NFA. So for this question, if we want to construct NFA, so we can do this like 0 and 1, all the combination of 0 and 1. So make a one state, that is A, that is initial state. It will have self loop of 0 and 1. Okay, so this will do all the transition or for all the combination of 0 and 1. That after our last the second condition is last symbol should be what? 1 and 1. So 1, you will be in a B state, and 1, then here you are at state C. So this how you can easily construct a NFA for this question. Okay, now this is NFA. Okay, one thing is that you should remember is every NFA can be converted to its equivalent DFA. Okay, so these are equivalent. This is equivalence between NFA and DFA, that every NFA is converted to its corresponding DFA. Okay, while conversion from NFA to DFA, one thing that you should always remember is the language is accepted by machine should not be changed. Okay, so the language accepted by this NFA, and if you convert this NFA to DFA and the language accepted by that DFA, okay, so in both cases the language should not be changed. The language should be same. The language is for this machine, it should be same as for the converted DFA. Okay, so this is the condition you should always remember. So how we can convert this NFA to DFA is, see, this is a very simple procedure. See, first draw the initial state like this. Okay, now after this just look this machine from state A. See, there are two input symbols, that is 0 and 1. So from this state first we will see the transition for 0. So for this from this machine from state A for transition 0, how many on which states you are basically reaching? From state A 0 transition, there is a self loop, you are reaching to the same state. So this have 0. Okay, so this is a complete. Now this one, for this one, so from state A we have two transitions for 1. In one case you are on the same state, and in the second case you are reaching to this B state. So you are having what? Two states, that is A and B. Okay, if the result you are getting in this case, that is A and B in this case of 1. Okay, and this is the new state. Okay, the number of state that you are getting after the transition is the new state if it is not present in the existing diagram. So here we have only one, that is A, that's single A, but in this case you are getting two states, that is A and B. So you have to draw a second state, that will be A and B, and this is getting after the transition 1. Okay, so this is how you are converting. First you have to see in the transition for both the symbols, that is 0 and 1. For the 0 you have a self loop, for the 1 you have what, A and 1. Okay, so both the transitions done for 0 and 1. Now look at this new state. Okay, so in this new state again you have to do the transitions. So but now how you can do the transition here, first from A and then B, like 0. If you are looking for 0, so from A, for the 0 transition you will have what, A, and from B you have no transition for the 0, so you will get what, 5. Now the union of these two is what, A, so finally you are getting what, A. So that means from this state, if we are making transition for 0, so you will get what, A, and A is already present here, so you do not need to write again. So this is 0. Okay, so 0 is complete. Now that is 1. Okay, for 1, so we have two states that we have only earlier seen, that A and B. From state A, so you have A and B, and from B state you will get what, C, and after that you will get what, A, B and C. So this is the new the final state. So this is not present here, so again you have to draw for 1, that is A, B and C. Okay, now A, B and C. Again from the we have done both the transitions 0 and 1. Now this stage is complete. Now from this we have to do this process till we are not getting a new state. Okay, so from A, for the 0 transition you will get what, A. From B there is no transition for 0, so you will get what, 5. And from C as well we have no 0 transition, so again you will get what, 5. So finally you will get what, A, and A is already present here. So from this state to this you will get what, 0. Now for looking for a transition 1, so from A we have what, A and B. From B you will get what, C, and from C there is no transition for 1, so you will get what, 5. So finally you will get what, A, B and C, and ABC is already present here, so mark as a self loop for 1. Now no more new states, and all the transitions have done for 0 and 1. So now last step is you have to mark the final states. So we already have drawn the first, that is initial state. Now final state is what, mark every state as final state wherever C is present. So in this case what we have, that this, so this is our final state. Okay, so now this is a complete, now this becomes complete. So this is a equivalent DFA for this NFA. Okay, so this is how we convert from NFA to DFA. Okay, in the next class, next lecture, we will see some more examples of the conversion from NFA to DFA. Okay.